Okay, continuing on. When the multiplicity is that's a big word, so we usually just use a capital M here. Okay, so when the multiplicity is odd, meaning 1, 3, 5, 7, or so on, the graph crosses the x-axis at that zero. I'm going to just squeeze that in here, at the zero. Okay. When the multiplicity is an even number, the graph touches the x-axis at the zero. Okay, so let me ask you questions about that. What is it doing? Is it crossing or touching? This is how we figure that out. And let me demonstrate it using this example again. Okay, this is considered odd multiplicity because it happened 3 times. So at x equals -3, right here, what does the graph do? Crosses through the x-axis at that 0. Here we have an example of even multiplicity. So since it has even multiplicity, at the spot of 2, the graph comes down and touches the x-axis and turns in the other direction. Okay? All right, so here we go. That was a lot to throw at you, a lot of characteristics, review as needed. Let's look at 7. Find all zeros of the polynomial function. Okay, let's start there. So we want to replace this with 0 and start solving it. Okay? And this is where you just got to use your algebra skills. The square root method is probably the best way to go through this. I mean, our backup formula is the quadratic formula because it is quadratic, but I'm going to add the x squared to the other side. That also gets a to be positive. All right, and now I want to take the square root of both sides. So I get x equals plus or minus 5. Okay, what else do they ask us to do? Determine the multiplicity of each zero. All right, so my zeros are this, right? 5 with multiplicity of 1 and -5 with multiplicity of 1. Or I guess you can make one statement if you wanted to, since they had the same multiplicity. Okay, you might be wondering, how do I know it's multiplicity of 1? I know it wasn't broken down into factors. I could have used difference of 2 squares to break it down to factors. But remember, it's second degree. I can't have more than 2 zeros, right? The max number of zeros you can have is the degree of the polynomial. So there's no way I could call this anything more than multiplicity of 1. Okay. All right, number 8. This is a good chance for you to pause and interact and you do some work here. They already took out the 4x, but you can continue to break this down a little more and find all the zeros, okay, and answer all these questions. Oh, I didn't quite finish this. Hold on a minute. Identify the maximum number of turning points. So the maximum number of turning points is n minus 1, okay? The degree minus 1. So 2 minus 1 turning points. Okay, so the max number of turning points. So max number of, I'll put TP, is 1. Okay, here you got a lot of solutions here, right? They asked for the zeros and the multiplicity. We did that. Identify the max number of turning points, and then use a graphing utility to graph the function and verify your answers. Okay, so I threw that in there. I took a look at this graph. Does it look like 5 and -5 are my zeros? Yep. Does it have just one turning point? Yep. And does it cross the x-axis? Because those are odd multiplicities. Sure. So it just helps me verify my answers. Okay, but you don't actually have to write this down. Okay. All right. Go ahead and pause and try number 8. Okay, here it is factored. Now we set 4x equal to 0. We divide by 4 and we get a 0. So the zeros are 0 with multiplicity of what? Track it back to its exponent. This only occurred once. So it has a multiplicity of 1. This one, I add 3 to both sides to get 3. So 3 is a 0 with multiplicity of what? Happens twice. Okay. All right, then the max number of turning points. Hopefully you recognize this as a third degree function. Look at our zeros too, right? 2 and 1, so there's 3 zeros. Or you could realize when you distributed this, your leading term or biggest term would be 4x to the third power. Okay, so 3 minus 1. So at most, there's 2 turning points. Okay, let's go ahead and take a look at the next one. Okay, here's the plan to wrap this up. We're going to skip 10, cross that out. I'm going to get you going on 9, pause and let you try to finish it. 11, I want to save for the next lesson, and then we'll do 11, 12, 13, and 14 on the next lesson, and also kind of review this section on day 2, okay? All right, so here we go. Number 9, sorry. Find the zeros. So 0 equals, now right away, we can see a common factor. Whenever you can factor out a common factor, you want to do that. All right, so we should write x squared out front, and then we're just kind of filling in the blank. X squared times what gives me x to the 4th? X squared. X squared times what gives me 8x cubed? 8x. And the last one minus 20, okay? All right, so I got this going for you. You continue to break this down and factor this. Find your zeros, state the multiplicity, get your max number of turning points. And if you want to answer over here, go ahead because we're not using the space. Pause now. Okay, so if you factor this correctly, factors of negative 20 that up to 8 are 10 and negative 2. Okay, so now I can set all 3 of these factors equal to 0 separately. 0 product law again. So here we are. Take the square root of both sides, and we get 0. So 0 has multiplicity of 2 because of the exponent, right? It happens twice, right? X squared is like x times x. Maybe even broke that down as x times x. I don't know. But we should say multiplicity of 2. This one, though, has an exponent of 1 and an exponent of 1, so these both have a multiplicity of 1. Negative 10 and 2 are the zeros. Okay, 4th degree function, so at most 3 turning points. You can verify all this stuff with your graph. Sometimes these have really big windows, like this turning point on this one's all the way down to like almost 1400. So you could try zoom fits, but if you're not comfortable with it, don't worry. You can do this by hand, but you could verify these x-intercepts, all 3 of them, and the fact that 0, it turns. And then at 2, it goes through. Okay? All right, that's it for today. You can get the assignment off Google Classroom. I'll talk to you soon.